Edison had over 1,000 patents. Tesla had around 300. Edison won the war of currents. His DC system powered America first, neighborhood by neighborhood, city by city. So why do we use AC today? Why does every power line, every outlet, every grid on the planet run on Tesla's system, not Edison's? If Edison won, why did his system completely disappear? People say AC won because it's more efficient. But what does that even mean? Efficient at what? The answer isn't about genius or business deals, it's about what electricity actually is when it moves. The secret Edison couldn't steal wasn't an invention, it was understanding what happens when you let electricity oscillate. Let me start with what Edison built. Direct current, DC. It flows one direction, like a battery. Simple, intuitive. Current flows like water through a pipe, from high voltage to low voltage, pushing electrons along. And it works great. For about 1 block. The problem is voltage drop. Send DC. Any distance and you lose energy to resistance in the wires. The further you go, the more you lose. Now, higher voltage means less energy lost, but high voltage DC at the destination is dangerous and there was no easy way to step that voltage back down. So, Edison's solution? Don't send it far. Build more power stations. 1 every mile or so. Expensive. Limited. But it worked. By the 1890s, Edison's Pearl Street station was powering Lower Manhattan, and he had stations scattered across New York. Each one served a small radius. You couldn't go far. The physics wouldn't let you. If you wanted to power a city, you needed dozens of stations. If you wanted to power a country, forget it. The system didn't scale, and Edison knew this. He knew it was a limitation, but he also understood DC deeply. He'd built his entire electrical empire on it. So what did Tesla see that Edison missed? What was the thing that let AC do what DC couldn't? It wasn't just alternating the current, it was deeper than that. AC is alternating current. The current reverses direction 60 times per second, which sounds completely insane. Electricity going back and forth? But here's the thing, and this is what most people miss, it's not moving back and forth in space. The electrons barely move at all. What moves is the wave, the oscillation of the electric field itself. Think of it like shaking a rope. You shake one end, a wave travels down the rope fast, but the rope itself just jiggles in place. Well, not exactly a rope, more like the electrons are all jiggling together, in rhythm. The wave carries energy through the electrons without the electrons having to travel far. That's AC. The frequency, 60 Hz, means 60 complete oscillations every second. 60 times the current flows one way, then reverses, then flows back. Now here's what changes everything. Transformers, simple device, 2 coils of wire wrapped around an iron core. You run AC through one coil, and it induces a current in the other coil. No physical connection between them. The ratio of the number of turns in each coil determines the voltage change. 100 turns on one side, 10 turns on the other. Voltage drops by a factor of 10, current increases by a factor of 10. Power stays roughly constant minus small losses to heat. And this only works with AC. Why? Because transformation requires a changing magnetic field. DC creates a steady magnetic field. It just sits there. AC creates an oscillating field, back and forth, 60 times per second. That oscillating field induces current in the second coil. Steady field does nothing, so you can step voltage up for transmission. Say you generate power at 25,000 volts. Step it up to 500,000 volts for the long-distance transmission lines. Why? Because at higher voltage, you need less current to transmit the same power, and current is what causes resistance losses in the wires. Less current means less energy lost as heat. Then when the power reaches your neighborhood, you step it back down to 7,200 volts, then down again to 120 or 240 volts for your house. Safe. Usable. Each step is just a transformer, copper coils, iron core, no moving parts. Passive device lasts 30 years with zero maintenance. Edison had no equivalent for DC. He tried. He understood DC profoundly. To him, current was the thing moving. Electrons flowing from point A to point B carrying energy with them. But AC requires different thinking. With AC, current is the effect of something else moving. The field oscillates, the electrons respond to that oscillation, and energy travels as a wave. Or another way to think about it, DC is like pushing water through pipes. You push harder, it flows faster. AC is like making waves in water. The wave carries energy across the surface, but the water molecules themselves just bob up and down. They don't go anywhere. Edison kept trying to make DC transformers. Kept trying to find ways to change voltage without loss. Couldn't work. No changing field, no induction. But Tesla understood something even deeper. Resonance. Everything has a natural frequency it wants to oscillate at. A wine glass, a bridge, a circuit. Match that frequency and you get massive energy transfer with minimal effort. Tesla coils demonstrate this beautifully. Two circuits tuned to the same resonant frequency. Energy jumps wirelessly between them. I've seen this demonstrated. Small coil on one side of the room, lights a bulb several feet away. No wires connecting them, just resonant coupling. The circuits are tuned to vibrate at the same frequency, so energy transfers efficiently through the electromagnetic field between them. This is exactly how modern wireless charging pads work, by the way. Same principle Tesla was showing off in 1891, and this gets to the heart of why Edison couldn't steal it. It wasn't about patents or circuit diagrams. Edison thought in terms of pushing electrons harder. More voltage, more current, more stations. Tesla thought in terms of making electrons dance. Let them oscillate at their natural frequency. Let them resonate. Let the wave do the work. Two completely different ways of thinking about the same phenomenon. Edison saw electricity as a substance to control. Tesla saw it as a wave to shape. At Columbia College in 1891, Tesla sent high-frequency AC current through his own body to light a bulb in his hand. High voltage, but because the frequency was so high, the current was tiny. It couldn't hurt him. You can't do that with DC. Try it and you're dead. But wait, where does 60 Hz come from? Why that specific frequency? It's not fundamental to nature. It's a compromise. Lower frequencies, like 25 Hz, cause visible flicker in lights. Transformers hum loudly. People noticed. Higher frequencies, like 400 Hz, which aircraft use, are more efficient in some ways, but harder to generate. Mechanically, and you get more losses in the transmission wires. 60 Hz in North America, 50 Hz in most of the rest of the world, turned out to be the sweet spot. Good enough efficiency, no visible flicker, manageable engineering. Originally, it wasn't even standardized. Some cities ran 25 Hz, some 40, some 60. Tesla advocated for 60. Westinghouse eventually adopted it as standard, and once the grid locked into a frequency, everyone had to match it. Which raises an interesting question. What is synchronization at this scale? Every generator on the North American grid has to oscillate at exactly 60 Hz, in phase with every other generator. Thousands of power plants, all locked together electromagnetically. If one starts to drift out of sync, the grid forces it back, or it disconnects. The entire continent breathing together 60 times per second. That's not something Edison ever imagined. His vision was local, discrete, individual power. Stations serving individual neighborhoods. Tesla's vision was systemic, a network. Let the AC wave propagate everywhere, step voltages up and down as needed, synchronize generators across vast distances. Different kind of thinking entirely. So let me circle back. Edison saw electricity as a substance. Push it, contain it, measure it directly, control the flow. Tesla saw electricity as a wave phenomenon. Let it oscillate, let it resonate, let it transform. And here's the key. These aren't better or worse philosophies. They're different types of thinking suited to different problems. DC is perfect for batteries, electronics, local systems, precise control. You want DC in your phone, your laptop, your car's electronics. AC is perfect for transmission, transformation, distribution across long distances. You want AC for the power grid. The modern world uses both. Your phone charger converts AC from the wall to DC for your battery. Solar panels generate DC, convert it to AC to feed the grid, then back to DC for devices. So the war of currents was a false choice. Both were needed. But the real insight, the thing Edison couldn't steal, was understanding that oscillation unlocks transformation. Tesla saw you could manipulate the wave without directly touching the current. Change the frequency, change the voltage, change the phase, all by changing the geometry of the coils. The number of turns, the core material, the spacing. Shape the wave by shaping the physical structure. This is completely invisible if you're thinking in DC terms. In DC, the wire is just a conductor. In AC, the wire geometry is part of the circuit's electromagnetic behavior. The wave cares about shape. Here's how you know this works. Look at a power transmission system. Power leaves the generating station at around 25,000 volts. Gets stepped up to 500,000 volts or higher for the long-distance transmission lines. Those huge towers you see carrying power across the countryside, Then it enters your neighborhood and gets stepped down to 7,200 volts. Then gets stepped down again at the transformer on your street, that cylinder on the power pole, down to 120 or 240 volts for your house. 4 or 5 different voltage levels. Each transformation is a simple transformer. Copper coils, iron core. That's it. No electronics, no active components, no maintenance. Try building a DC system that steps voltage up and down like that. You need power electronics, conversion circuits, switching components, control systems. Modern high-voltage DC transmission exists. It's actually making a comeback for very specific applications, but it requires active electronics at every voltage transformation. Complex, expensive components that wear out. The elegant simplicity of AC transformation is exactly why AC won. Not politics and not business. Physics. The most reliable, efficient way to move electrical energy long distances is to let it oscillate, step up the voltage, transmit at high voltage with low current, then step back down. Transformers make this trivial, and transformers only work with changing fields. AC gives you changing fields automatically. Now, Tesla's broader vision went even further. Wireless power transmission. Not just resonant coupling over a few feet, but power transmitted through the Earth itself. That was Wardenclyffe Tower, his project from 1901. The idea was that the Earth resonates at certain frequencies. This is real, by the way, the Schumann resonance, around 7.83 Hz. Could you transmit power by matching that frequency? Use the planet as the medium? He never completed the project. Ran out of funding. Was it possible? Still debated. Small-scale resonant coupling definitely works. Planetary scale? Unknown. We've never tried it properly. Modern wireless charging uses the same principle Tesla demonstrated. Resonant inductive coupling. Just at very limited range. So maybe Edison understood what electricity is. The flow of charge. The movement of electrons. Voltage. Current. Resistance. He understood that intimately. Built an empire on it. But Tesla understood what electricity could be if you let it oscillate. If you stopped trying to push it and started trying to shape it. Resonance, transformation, wave propagation, electromagnetic fields dancing together in sync. Different way of seeing the same reality, and it turned out that for building a power grid, for electrifying continents, the wave perspective was exactly what you needed. The secret wasn't alternating current itself. Engineers knew about AC before Tesla. What Tesla understood was that oscillation enables transformation, that matching frequencies enables resonance, that you can shape energy by shaping waves. Edison never saw it that way. He kept looking for ways to make DC do what AC does naturally. Kept trying to push electrons harder, send them farther, control them more precisely. The paradigm shift. The thing that couldn't be stolen was recognizing that sometimes you don't fight the physics, you dance with it. Which raises the next question. Why does resonance allow such efficient energy transfer? Why do matched frequencies couple so strongly? What is it about oscillating systems that lets them exchange energy with such minimal loss? That gets into quantum mechanics and field theory, the deeper structure of how waves interact. Different story, but you can feel it in a way when you push someone on a swing. Push at the right rhythm, match their natural frequency, and tiny effort creates huge motion. Push at the wrong time and you're fighting them. Tesla saw that in electricity. Edison never did.